Thank you. So this is it's turning into kind of an annual update on our work here. The Lunar and Planetary Mapping and Modeling Program that's administered by Survey and is actually developed at JPL consists of a set of data products, interactive tools, and technology for exploring the surfaces of other worlds. It's useful for mission planning, science, research, as well as education and public outreach. It provides for data visualization, analysis, 3D printing, and a variety of data services. Right now we have portals implemented for the Earth's moon, for Vesta, for Mars, and for Earth. A variety of user interfaces, the most common being the web browser, and that's what we'll focus on today. Our initial platform was the Lunar Mapping and Modeling Portal, or LMMP. It was originally designed as part of the Constellation program for site selection and analysis of potential landing sites on the moon. It consists of a variety of analysis tools, including lighting, slope, hazards. It allows you to browse and search a wide variety of data. We have over 700 layers of data, doing very extensive visualization of data, being able to stack data layers, adjust them, collaborate between people, share information, data coming from a variety of instruments on a variety of spacecraft, and put to a variety of uses. Let's take a look at an example of LMMP at work. So here we're taking a look at the region of the Marius Hills, one of the more spectacular volcanic formations on the surface of the moon. And as you look here, you may be somewhat less than overwhelmed. I mean, these volcanic cones are not really leaping out at us here. This is a photographic image from the wide-angle camera aboard LRO. But if we switch to laser altimetry, we can see that, in fact, these cones are there, and they do really leap out. So depending on the instrument you use, that can make a huge difference. We can also draw a transect, draw a line through the Marius Hills, and we can see that, in fact, there is a large underlying shield beneath this cluster of cones. If you've ever been to Hilo in Hawaii and looked up at the broad shield of Mauna Kea and seen all the cinder cones on top, this is somewhat reminiscent of that. Here's a view of the same area. Now we're looking at a gravity map. This is a free air gravity map from the Kaguya spacecraft. And as I mentioned before, you can stack multiple layers. So we'll have the laser altimetry beneath, and then we have the gravity adjusting the transparency such that you can actually see, now we can visualize the now solidified, unerupted plug of magma beneath this volcanic center. As you make these types of adjustments, you'll probably want to save them and share them. That's very easily done. Since this is all done in a web browser, you simply generate a URL that you can then send to any of your colleagues. When they get it, they just paste that into their browser. It will take them to the same place, load the same layers, the same zoom level, the same transparencies, so it makes it very easy to share your visualizations. Further examples, let's go to Tycho Crater. Here we see a narrow angle camera mosaic of the central peak of Tycho. Here is, again, a digital elevation model helping us to better visualize the topography. Here is a 15-meter roughness map. If you're planning a traverse across the central peak of Tycho Crater, all this red is something that is going to keep you up at night. This is not good news. But again, this is at 15-meter resolution, and the fact of the matter is your rover probably has significantly less than a 15-meter wheelbase. If we drop down to something a little more reasonable, like a 3-meter resolution, we see that the picture is entirely different. So again, the data that you are visualizing can make a huge difference. Similar, we can do things with maps of slope. And we can create 3D visualizations and actually do flyovers. There's been a real evolution in the digital elevation models. Here we're looking at a series of volcanoes, the Hortensius domes. Again, these don't stand out at all in just regular imagery, but with the laser altimetry on Lola there, you can see the dome standing out. This is our initial version that we were using, version 4 of Lola. The upgrade to version 6, you can see much more detail. And in our latest version, which is the Lola and Kaguya terrain camera stereo merge, the level of detail really is fantastic. So it just keeps getting better. A lot of activity now at the poles of the moon, a lot of interest. We had a very interesting workshop this past Sunday on the Resource Prospector mission. So of course we are focusing a lot of our interest on the poles. Here is a look at the North Polar region around near the area of the crater Perry, and you can see a lot of permanently shadowed craters. That's good, but it also makes it hard to plan. But using laser altimetry, we can see inside those shadows, slope maps, and we can then overlay where the permanent shadows are. These are areas of particular interest to us in terms of looking for potential sites for water ice. Our program is developing a number of data products for the Resource Prospector mission. So these are some data products that we developed for them in their investigation of perhaps sending their rover possibly to the crater Perry. In addition, they're generating some of their own data products, which we are then integrating. So this is a data product that they did of the crater Erlanger, which is off to the side of Perry there. And so as they are generating data products, we're working with them to integrate them into the full suite here. Some of the newer products that we now have the North and South Polar mosaics from the Mini RF instrument. This includes circular polarization ratios and the first Stokes parameter. Now, with any of our portals, one of the really cool things you can do is you can draw a bounding box around any piece of terrain that you like. And once you have done so, if you happen to have a 3D printer hooked up to your computer, you can print that terrain. This is really popular. And actually, our friends at Resource Prospector Mission are talking about putting together a nice tiled mosaic of these prints of some of the areas that they're thinking of exploring. So in terms of mission support, we're working with Resource Prospector. We're working with Lunar Mission 1 mission. And we're also involved with the upcoming lunar CubeSats, especially those flying on EM1, in discussions of data management. I think, there we go. So we have some challenges coming up here. One of the things that has been forced upon us is we're having to redesign our client interface. This is due to the deprecation of Flash software, and so we're having to come up with something entirely new. There's some good sides to that. We will end up with enhanced GPU integration. We'll have a common client infrastructure across the various worlds that we are mapping and modeling. But we're going to end up also having to upgrade the back-end services to a common framework across all of these platforms. And as we talk about the back end, that means capacity upgrades. As we've added new worlds, Mars and Vesta, we've gotten a lot more users and a whole lot more data. And so our back end has to be upgraded. We're streamlining the vetting of information for metadata inclusion, getting these data products in more quickly. But what all this means is some of the formerly automated processes are currently requiring manual intervention and oversight by our staff. This is a temporary situation. This is going to be continuing through this fall, but we will be releasing our new product, our new Moontrek this fall, so keep your eyes open. It will be a far better product. On to Vesta. Vesta Trek, jpl.nasa.gov, was launched last year, and it allows us to visualize the surface of Vesta using data from the Dawn mission. Beautiful 3D visualizations. You can add different layers. You can spin the globe of Vesta and use game controls to fly down to the surface. Here we're looking at some wonderful views of pitted terrain where ice has volatilized and erupted, leaving these wonderful pits. We can bring up a mineralogy ratio layer to actually bring that out more clearly. Upcoming additions to VestaTrek, we're working with Tim Stubbs and getting the illumination and temperature maps. Those will be the next additions. And then on to Mars. Our newest portal, Mars Trek, has a variety of tools. Again, it started out as a public outreach tool, but is expanding to more than that. It allows you to visualize the surface of Mars through the eyes of many different instruments on a variety of different spacecraft. Here we see Valles Marineris viewed through the Themis instrument on NASA's Mars Odyssey spacecraft. This is daytime infrared view. The battery in this clicker is going, oops, back up just a little bit. Here we see MOLA laser altimetry of the Casey-Valles area. This is a really spectacular outflow channel and is one of the places that we are looking at as a potential site for human exploration on Mars. This is Mount Sharp in the center of Gale Crater. Gale Crater is where the Curiosity rover is currently exploring, and this is a view using the CTX data from the CTX camera aboard the Mars Reconnaissance Orbiter. Columbia Hills area of Gusev Crater, showing Spirit rover's path in green. One of the things we were asked to do by headquarters was to add a special feature at the time of the release of the movie The Martian. And so now you have the ability to follow the epic journey of astronaut Mark Watney across the moon, or across the surface of Mars, and see exciting commentary from Jim Green, our Director of Planetary Sciences. Here we see Victoria Crater view. This is actually data that was obtained from orbit, but we're able to put ourselves down on the rim of the crater and get essentially a rover's eye view. This is again with the HiRISE camera, data from the HiRISE camera on the Mars Reconnaissance Orbiter. It's the 40th anniversary of Viking. Hooray! And so we are adding some new information. Here you can see we've got data on the two Viking missions. And using HiRISE, we can actually see there the Viking lander. There's the heat shield lying off to the side. There's the back shell. Again, we're looking at different areas. You can see the back shell, but even more interestingly, if you look, you can actually see the parachute draped across the ground just to the south of the back shell. That's pretty cool. We have integrated with another NASA product, Experience Curiosity. So for the Curiosity mission, you can actually see through the eyes of the rover, ground-based views. We are adding exploration zones. So last fall there was a meeting in Houston and people got together to look at where we're going to send humans to the surface on Mars, come up with 47 potential sites, and these will be added to Mars Trek very soon so that the public will be able to join us in the exploration of these really exciting sites and see why they are in fact so exciting. There are a number of maps that are being added and data layers that will be added in support of this. Geologic map, valley networks, dune fields. Here you can see actually a depiction of how right now Curiosity is crossing one of those dune fields. Additional layers, MOLA vertical roughness, a number of layers from the TESS instrument. And a lot more coming. I won't go into the whole list. I'll just point out, though, that one of the things our project has done is worked with the USGS in producing CTX mosaics, higher resolution than what we have typically had in the past for each of these exploration zones. We've got a number of things, a touch table interface. So in addition to our web interface, we have touch table, 3D goggles, hyperwall, and we're able to serve data to outside items through our outside platforms through our APIs. Coming up, we're also going to be able to output our 3D models in OBJ format, which means now you'll be able to have texture, not just shape. And we are expanding our collaborations, working with the European Space Agency, CARA, the NESF Citizen Science Forum, a number of planetariums. We've become part of the NASA education infrastructure. And whoops, we're adding time series that's going to be coming up. That'll be useful for resource prospector communications and illumination maps, Marcy views of Martian weather, and we're even going to be including Diviner lunar global surface temperatures, a really huge data set from July 2009, binned at 0.5 degree resolution and 15-minute intervals. So that's going to be an exciting addition. It'll be a big addition. A number of additional capabilities, including VR and AR, come across the hallway to room 103 and 104, and you'll see, you'll get to try that out. Looking ahead to, we have a prototype for a series we're working on that we hope to release in the not too distant future. And for those of you who were here for the Phobos and Deimos, there was a wonderful talk. Whoops. There's a wonderful talk given by Conrad Vilner on the coverage now coming back from the Mars Express mission on the moon Phobos. We definitely have our eyes on Phobos. So come visit our sites, LMMP, Vesta Trek, and Mars Trek, and come across the room and play with all of them. Thank you very much.
Are there any questions for Brian? Okay.
Thank you.
So I guess we have about 5, almost